The speaker is an algo engineer at Hudson River Trading, a high-frequency trading company. She also serves as a founding co-lead of their new women's employee resource group. Prior to that, she spent 6 years at Google working as a front-end engineer on Google Search and Google Drive and a back-end engineer on Google Maps. So, ladies and gentlemen, welcome Jessie Newman.
Thanks. Okay, so we're going to talk about unit testing best practices. So the way this is going to work is first we're going to talk a little bit about like why you should do unit testing, how it is going to like improve your life as a developer. And then we'll go through kind of like what are the best practices, like what is it you really want to be paying attention to when you're writing unit tests to make them really effective. And then we'll go through some Python examples of how you can use different Python tools to write your unit tests, including some newer Python tools. So, okay, everyone hates writing tests. That's pretty standard. So hopefully I can convince you that writing tests is going to be a good idea anyway. So the first thing I'll say is that good testing increases the lifetime of your code. And so it does that in a few different ways. So one is that if you're writing a really complicated API that a lot of people are using, a lot of times you'll have like some really commonly used code paths and then some that are like not used that frequently, but like still they're like important features that need to work. And so when you have these like less frequently used code paths, a lot of times like as the code around them changes, you'll find that those are getting stale. They like no longer have the same guarantees that they did when you originally wrote them. And so that's going to make your code last not as long. It's going to make you look a little bit like you're writing unreliable code. So by having testing, you can prevent that from happening. And you're going to be known for having very like reliable and robust code that lasts a long time. Additionally, you can get other people to make changes to your code. And so that's going to be both getting other teams to add features to your code, as well as like, you know, maybe your team's migrating to a new version of Pandas. And they, you know, someone's going through and trying to update everything. If you have tests, they're going to feel a lot safer updating your code as well. And so your code is going to like progress as the company progresses through different versions of Python and like different APIs because people feel safer making those changes to your code. Next, it also increases the impact of your code. So you're going to have more teams that are willing to use your code if they are like understanding how they can use it, as well as if they're able to add new features to it when they need to. And that this is going to come from a few places. So one is that having tests makes them more likely to add features, but also tests serve as really good documentation for the code. Like it's very much a copy and paste example of how someone can add your code to their like feature and like really integrate with it. So this is really going to help people find more impact with what they're building. Finally, good testing lets you take on more projects. Well-tested code is a lot easier to train new developers up on. So if you're hiring people and you have well-tested code, you're going to have new hires that are much more confident starting to add features to your code when they're not worried they're going to break it. And so that means that you're not going to be the only one maintaining it. And assuming that the code you've written is extremely impactful and widely used, you're probably going to get stuck maintaining it for a while. So having other people to help you maintain it is good. And in general, the more tests you have, the less you're going to have to maintain it anyway, because it's probably just going to keep working. So hopefully I can at least convince you that like, as much as writing tests kind of suck, it's like a very efficient use of your time that's going to like make the code you write just much more impactful, much more long lasting. It's going to really free up your time to start new impactful and long lasting projects. So before we get like deep into unit testing, I want to make sure we have like a definition of like what a unit test is. So there's a lot of different types of tests. The only ones I'm going to talk about today are unit testing and integration testing. And that's because those are kind of like the smallest chunks of tests. So a unit test tests a like very self-contained block of code. And because it's very small and self-contained, the test is going to be very fast and it's going to be super easy to debug because you know exactly, you know, if something breaks, you know where the breakage happened. An integration test is kind of the slightly bigger size test. So that tests that your small blocks of code work together. So you have, one class calling the next class, calling the next class. So integration tests are very important, but they are slower to run because you're calling a lot more code, and they're also harder to debug because there's a lot more places that the breakage could be happening. And so you definitely need both of these. But in general, you want to have a lot more unit tests and less integration tests. So if all the units are working great, then testing that they work together shouldn't be too strenuous of a process. So we're going to be talking about unit tests specifically. So what makes a good unit test? I have 5 things we're going to talk through. So the first one, unit tests should clearly explain what behavior they're testing. And so I have a few different examples of ways that you can do this. So the first, you can see here that we have 3 different tests, and it's very clear what these tests do from the name of the test function. So we have test get username, account ID is none. Test get username, account ID is in the database. Test get username, account ID is not in the database. And so those are the 3 things that we are testing with these 3 tests. That's very clear to someone who's trying to understand your code. Other ways to do this include adding comments. Sometimes people like to put all their tests under one test function. That's a fine way to do it. If you do that, you really want to make sure that you're still finding a way to describe what it is that each assertion is doing. So here we have comments that are explaining each of these. My favorite way of doing this is having very prettily defined variable names. So we have, assert get username for valid account ID gives you username, and get username for invalid account ID throws an error. And so, you can look at the string invalid account ID and be like, okay, I understand what it is that we're trying to test here from the way that we have named these variables and the content of them. So you can combine all 3 of these approaches. These are just a few different ways to make it very clear what's being tested so that your code can also serve as documentation for other people who are trying to understand how your code works. 2, unit tests should cover all use cases and edge cases for each public function. So we have this function here, play tic-tac-toe move. It takes in a player, it takes in an X and Y coordinate, and it returns true or false. Did the player win the game in response to this move? So if we were going to test a function like this, what are all the different things that we need to test? So we would want to test if you're, what are the different ways you can win tic-tac-toe? You can win by playing horizontally. You can win by playing vertically or by diagonally, or maybe you don't win. You just place a move and nothing happens. What are some of the invalid cases? So maybe you try to play somewhere, but a player has already played there, or you try to place a move, but it's out of bounds. Those are all types of cases that should be tested in your code. So the absolute ideal way to test would be really going line by line and thinking what the edge cases for every particular line is. In practice, that's really hard. So what I would recommend if you don't have all the time in the world is going to be first come up with every single edge case for the code you can think of, both in terms of valid input as well as in terms of invalid input, and then use a code coverage tool to try to check if you tested every line of code. Code coverage tools are not 100% perfect because sometimes they'll be like, oh, you tested this line, but you didn't test all the ways the line could work, So doing both of those together is going to get you to nearly 100%. 3, unit tests should test all public-facing functions and avoid testing private functions. So in this example, we have our remove odd numbers function, and this private function is even, that is used by remove odd numbers. So if you want to test this, what you would want to do is you would test remove odd numbers. You would not test is even. And that's because if someone refactors remove odd numbers to use a different way of doing this, or maybe they change the name of is even to is odd and have it do the opposite thing, that would be a totally valid design decision. And remove odd numbers still works. It still does exactly the same thing. But if you're testing the private functions, your test is gonna fail. And that's because you're testing the implementation details and not the inputs and outputs and edge cases. So that's going to cause a lot of flaky tests that fail even when nothing's wrong, and then no one's going to trust when the tests fail. And so really sticking to just testing public functions is going to help you avoid like having flakiness in your tests. Okay, 4, unit tests should contain as little logic as possible. So this is one of the biggest problems I see with tests. So we have this example here. We have this function, have same domains, and we want to test, does have same domains work? So what we do is we construct 2 different URLs, and we call have same domains with those URLs, and we check if the domains are equal. Or at least that's what we think we're doing in here. It turns out this function probably is testing a different thing than you expect. You probably expect that it's calling have same domains on google.com/maps and google.com/calendar and asserting that that is true. But os.path.join does actually some weird behavior when the strings have a slash in them. And so what is actually being called is this, assert have same domains /maps and /calendar. And so this is going to return true even if we break our have same domains code in a variety of ways. So this test is going to have a lot of false positives. And that happened because we introduced logic into our code that kind of hid what was actually happening from us. So a better way to test this would be to be very explicit about what it is that you're testing, just very, very verbose. And that's, I mean, like when you're writing code, you're writing bugs, right? That's the whole reason we're writing tests. So if you're putting a bunch of logic in your tests, like there's no tests that are testing your tests. Like you're just going to insert bugs into the tests. And so that's, you know, we've just messed the whole system up at this point. So I do want to call out, like in this particular example, the before was really long and the after was really short. That's just because I'm trying to not have you look at like a giant wall of text, but in practice, usually people are inserting logic into their tests because they want to make it shorter because there's a lot of duplicate code in their tests and they want to like simplify it. So, I mean, usually that's when this starts happening. And so I'd really recommend you like resist the urge to add logic in your tests to keep them shorter. Like verbosity is actually really good in this use case. You know, it's very important to like have no duplicate code in when you're writing code, but when you're writing tests, like there's different best practices, and being very verbose, even if it means duplicate code, is one of the best practices. 5, unit tests should not test code outside the scope of the test. So these code snippets on this page, we'll like zoom in on them on a later slide, so don't like feel obligated to read it super heavily. But what I will say is we, in general, we have this function get username, and it's calling into a database via an HTTP request and getting the username using an account ID. So if you are going to test this, if you didn't do anything special, it would actually call into the HTTP request, which may or may not work and is going to be really slow and like is going to depend on your network connectivity. And like that is not a good test because the things you're testing are things like network connectivity when you're supposed to be writing a test that tests the logic of the function. So this is the kind of example of things that you do not want to be calling into a database or calling a URL or really even calling another class because unit tests are supposed to be very self-contained. So we're trying to really only test the small chunk of code that we've said we're going to test. So how do you do that? We will cover this. Python testing tips. So we're going to zoom in on those examples, like I said. So again, we have our get username function. It takes in an account ID. Then we make an HTTP request. We pass in the account ID. We get the response, assert the response is OK. And then from the response, we access the JSON and we get the username field and we return that. So that is the function that we're testing. So how do we start mocking stuff out so that we can like keep it our test self-contained? So the first thing is using the patch decorator. This is located in the unittest.mock Python package. And what it does is if you use the patch decorator on your test function, it's going to replace that function with a magic mock, which is a type that's also located in unittest.mock. So I do want to like, so when we see this patch decorator, it says at patch, project.data.fetchData.request.get. And so that's saying we want the request.get function inside of the project.data.fetchData module. So going back to the previous slide, you can see, I mean, it's just annotated in here that this is what module that we're dealing with. And so that means that you're not mocking out the code in any other module. Only the request.get function inside this module is being mocked out. So if you get this string inside of @patch incorrect, it is not going to patch it out. So be very careful about that. Yes, so once you patch it, it's going to automatically be injected into your function. So we have this parameter being passed in of type magic mock that we're going to call mock client get. And this is our fake thing that request.get is being replaced with. So magic mock has a few different attributes on it. So the first one is return value. That says what should be returned when someone calls this function. And so what it returns is another mock. And so we're saying set the OK property on that return mock to true. So if someone calls request.get and they get a response and they check the OK attribute on it, it's going to be true. And it propagates in that same way. So if our get function returns a mock, which has a function JSON on it, which returns another mock, we're going to set that mock to be the dictionary username get name one, or username name one. So this is how we set properties on our mock. And what's going to happen now is if you call get username with any parameters, it's going to call, when it gets to request.get, it is always going to return an object that whose OK is set to true and whose JSON function returns username name one. And so now we can do some tests without actually calling into a server or anything. So let's make this a little bit more complicated. So what if you want to not just do a return value, but like you actually want to replace the whole function? You want to be able to do other stuff inside this function. So that's where side effect comes in. So instead of doing mock client get.return value, we do mock client get.side effect, and we set it to a new function. And so now when request.get gets called, what's actually going to get called is our fake get function. Okay. I want to just make sure there's no questions yet. I don't see any in the chat. Okay. So that allows you to entirely swap out the function. So that's very versatile. It gives you a lot of different options. Hold on. Yes, okay, so one of the different options it gives you is that now that we're replacing it with an entirely different function, we can actually add asserts inside of that function. So in this case, you can see at the top of our side effect function, we are doing assert URL is equal to the URL we expect, and assert params is equal to the parameters we expect. So now, not only is request.get returning what you expect, you're also doing some assertions when that gets called to make sure you're calling it with what you expect. And so this is really how you want to interact with things that are getting called outside of your code, outside of like the little section that you're testing. You want to make sure that you're calling it with the correct things, and then you specify what you want the return value to be so that you know all of the expected next steps in the test, or as it goes through the code. So the last thing I'll say on top of return values and side effects, side effect is overloaded, which is actually kind of confusing, and I hate that. But the way it is overloaded is, let's say you want the first time you call a function, it should return one thing, and the second time you call a function, it should return another thing. If you give side effect an array, that's going to be an array of return values. So in this code snippet, the first time we call mock client get, it's going to return our username one mock, and the second time it's going to return the username two mock. So that's kind of cool. So let's talk a little bit more about this mock object. So I glossed over this a little bit on the last slides, but you know, when we are setting these like OK and return value and stuff, we're setting those on a mock, right? And so you can create your own mocks and do stuff with them, and then have different functions return them. So I just want to take a moment to like just look at this. We're creating a mock. We're calling it username 1. We're setting some values on it. And now when we call mock client get, which is called when you call request.get, it's going to return the mock username 1. You can create mocks in a variety of different ways. This code does exactly the same thing as the other one. You can also set the type of a mock. So this is a part that's kind of cool. So if you have a mock and you call a function or attribute on that mock, it's going to return another mock, no matter what, no matter if that function exists or if that attribute exists. So if I were like in my code to be like, hey, what is request.get.hello, it would just return a mock. And so that's sometimes fine. That's sometimes weird. So if you want it to only return valid attributes and valid functions, you can give it the type of class that that mock represents. So in this case, we're saying our request.get is going to return a mock of type requests.response. And so now if you try to call hello on that, it's not going to work because request.response does not have a hello function. But if you try to call a function that does exist on request.response, then it will work and it will return a mock. Seal. So this is actually new in Python 3.7, and I like it a lot. So you might be thinking in that last section, like, okay, that sounds cool that you can like prevent it from creating functions that don't exist, but what if I want to do like what if you have like some object you're passing around and you're trying to do asserts on it where you're like asserting things don't exist, but they do exist because it's a mock and it's automatically creating stuff. So what seal does is it says anything that you have not specified up until this point will not be auto-created. So now we have our username mock, and if you tried to call hello on the username mock, even though it doesn't have a type, that is going to fail because you sealed it before you called that. So that is like saying, okay, the mock is complete. Any unspecified functions or unspecified attributes do not exist. So that's super helpful, and I think it's awesome, and I'm glad that they introduced it finally. Assert called with and call args. Let me see how I'm doing on time. Great. Okay. So yes, we had this example earlier where we created a side effect function, and that side effect, inside of it, we asserted some things about the parameters. So this is such a common thing you may want to be doing in a side effect function that you can actually do it in an easier way. So we have this assert called with function, and there's actually a variety of different like functions that are very similar to this. So things like assert called once with, to make sure it was only called one time. And what that does is it checks that the parameters your function were called with are the parameters that you wanted your function to be called with. And so that can make testing really easy. The one thing I will specify is that you have to pass the parameters in the exact same way. So like here, our first parameter, we did not name when we called it in the code. And our second parameter, we did use a name. We said params equals rather than just passing it in by like its index in the argument list. And so you have to access it that same way when doing assert called with. So if we did not have this params equals here, this assert called with would fail because that is not how we called the function. You can also access call args. If you want to do really complicated stuff, this is the way to like really get all of the details. So instead of being like assert it was called this way, you can be like, just give me all the call arguments. If you want to compare against another call that you construct, we have this call wrapper inside of unit test.mock, which lets you do really simple things like assert client get.callargs is equal to call, and then these parameters. So these last two slides do exactly the same thing. Assert called with does the same thing as call args equals call. But you have a little more flexibility with this one. You can make like matchers and stuff. Also new in Python 3.8 this time, we have the ability to access the args and kwargs parameters, not parameters, but you can access the args and kwargs directly. And so this is great because you used to really have to wrap it in a call or like index into it. And honestly, the syntax looked really gross and was really hard to remember. Like it just looked bad. And so this looks a lot nicer. You can access the kwargs and args, attributes, on-call args, and assert against them directly without having to create this call wrapper. I'm very happy with this introduction. Okay, this is our final thing we're going to be talking about, async. So Python introduced like async and await and stuff, and so we're seeing a lot more code in there. And so there are now ways to test asynchronous functions. So we're going to go back to our original example where we have our like get username function, and we're going to rewrite it to work in an asynchronous way. That's outside the scope of the talk. So just to like briefly go through this, we're going to create a client session. Inside that client section, we're going to await session.get, and then we're going to await response.json, and then we're going to return our JSON username. So just generally, this is now an async function that we're using async and await on. So how do we test this in Python? We have async mock. So instead of inside of your app patch decorator, by default, that puts in a magic mock. That's what gets injected to your function. So instead, we're going to be like, no, we want an async mock with this new callable equals async mock parameter. And then now an async mock is going to be passed in. And basically, anytime you were gonna create a mock before, now you create an async mock. And once you do that, it basically just works perfectly. So you have to call await on the async mocks, and then it just works. So the important thing to note is I also have this decorator up here, pytest.mark.asyncio. The reason for that is a really common way to be running these tests is via PyTest. So if you're running your test via PyTest and you want it to run asynchronously, if you add this decorator onto your test, it is just going to run asynchronously. Like that is going to be enough for PyTest to know how to handle the test. Otherwise, your test is not going to work because you can't just call asynchronous code from inside a synchronous process. So this is a very important decorator if you are using PyTest. That is the end of everything I have to say about unit testing in Python. I ran through that quicker than I meant to, so we are 10 minutes early. But thank you so much for listening. If you have any questions, feel free to reach out to me on Twitter or LinkedIn, and I will be staying for the Q&A session as well.